Now in this case we have to basically discuss the stability of alkene. So again we have to compare with a mono or di substituted or tri substituted. So this is about the stability of alkene. Now you see the first one. So this says 1-methyl cyclohexene. So you have a cyclohexene molecule, and position number 1 you have a methyl group. So this is 1-methyl cyclohexene or 3-methyl cyclohexene. So this is 3-methyl, and position number 1 you have a double bond. So 1 2 3. So this is 3-methyl cyclohexene. This is 1-methyl cyclohexene. You can call one, this one is 1. So now which is more stable? This is basically a tri-substituted hydrogen. You have a methyl group here you have. So this is a tri-substituted alkene, and this one is basically di-substituted. This side hydrogen, this side hydrogen. So this is di-substituted. Di-substituted. Now if this is di-substituted, this is tri-substituted. This means this is more stable. Are you getting? Now let us say the B1. So this is part A. This says isopropenyl cyclopentane. Isopropenyl. What is isopropene? Iso group is this CH3CH2 and CH3, and if I remove one hydrogen from here and if I add one something, this group is called isopropane group, isopropyl group. So this is isopropyl. So this is isopropyl group. This we have discussed. Now if I make a double bond here, this becomes isopropenyl. So this becomes CH3, and then you have CH, you have double bond CH2, and now this group is called isopropenyl group. Isopropenyl group. Isopropenyl. And I have to add a cyclopentane here. So here I have to add a cyclopentane. So this is the first compound. Now the next compound you have, this is allyl cyclopentane. Allyl group is this. You have already discussed. What is allyl group? CH3, CH2 double bond. There should be no CH2. Now CH2, and if I remove one hydrogen from here and put CH2, and this group is called allyl group. So this group is called allyl group. So we have allyl group. Now if I add here something, so what is this? We have to add a cyclopentane, because I have to keep the constant. This is a pentane, allyl cyclopentane. So I have to add here cyclopentane. So CH2CH double bond CH2. Here you have hydrogen, and here you have cyclopentane. Now tell me which is more stable. This side you have a basically di-substituted alkene, but here you have 1, 2 and 3. So this is a tri-substituted alkene. This is one substituted, this is another substitution. Oh, this is also di-substituted, but this is not di-substituted, this is a mono-substituted. So this one is mono-substituted, this one is mono-substituted, and this one is di-substituted. So this is more stable. So this one is di-substituted, so more stable. So this is more stable. Let us discuss the next part, C. Now this says we have this compound, these two, we have to compare among these two. Now we can discuss here itself. This compound is a double bond in the 4-membered ring. In this case, double bond inside the 6-membered ring. Double bond inside the 6-membered is less strand, so this is more stable. Double bond in the 4-membered ring is more strand, so this is less stable, and this one is more stable. More stable. Why? Because double bond inside the 6-membered ring is more stable. So I can write this thing: double bond inside the 6-membered ring, inside the 6-membered ring is less strand, easy one. So if it's less strand, you will have more stability. Now D part says you have Z cyclononane and E cyclononane, so 9 carbon. So you have a cyclo group with a 9 carbon. So it's easy to draw this one. So let us try this one. So you will have something like this, and then this you have to have 9 carbon. So let us compare 1 2 3 4 5 6 7 8 9. So this is your 9 carbon. You can make a cis or trans both for this compound. So let us make this one. So you have this, you have this, slightly difficult to make. Now this is one compound. Next we will make the trans form. So you will have this. Now this is the cis and trans. So let us say this is cis, and you can take a trans also. So you will have this side hydrogen, this side hydrogen. This is cis, that is Z form. Now in one case you have hydrogen this side, in another case hydrogen this side. Basically this is trans. So you see in this case, if you remember, and the trans is called E, so let us write E here. So this is E isomer. Now you see in this case geometry does not permit this kind of diagram, or you can say this kind of a structure. This means this is less stable and this is more stable. And this is basically possible if the ring size is just small. Cis isomer is more stable, so this is more stable. You can remember if the ring size is small, geometry does not permit, and cis isomer is more stable for a small ring size. So now I can write for a small ring size, for a small ring size, cis isomer or Z isomer, cis isomer is more stable. But if the ring size is large, the reverse is true. That is the same, the next problem. So E you have, you see in this case you have cyclooctadecane. Octadecane means 18. Cyclooctadecane, and then you have cis as well as trans. So 18 carbon. You have to have 18 carbon. And let us try to make this one 18 carbon. So you have to make 18 carbon. So just wait for some time and then you copy this thing. So you have this, and then this side same thing you will have, and then here also you have the same thing, and then you have, I think, you have to have something like this. Now it's okay. Now you can copy. So this is the compound you have. Now one case you will have cis and another case you will have trans. So let us say this is the cis case. In this case you have hydrogen this side and hydrogen this side. So this is cis, that is Z isomer. Now similarly you can make the trans isomer, but that time you just put this double bond here. So there is a trick. So now I will have this. Now this side you have a double bond, and this side also you have something like this. So slowly we are able to do this one. Now this is the 9 carbon. This time put the double bond here, and now so something like this hydrogen here, something this hydrogen here, and now geometry this time. So this is Z isomer. Geometry permits this kind of a structure. So this case you will have trans is more stable, that is E is more stable. This is because if ring size is more than 10, around 10 or 11, if ring size is bigger, trans isomer becomes more stable. So if ring size is larger, ring size is larger, trans isomer becomes more stable. You can remember these things, becomes more stable, even though these things are not asked in JE, but you can remember, becomes more stable. So for a smaller size is more stable, for larger size of ring trans is more stable.